Hi everyone, welcome to SA Online Academy, your own channel to learn, explore and grow. In the last video, I shared quiz questions of chapter 1 with all of you. I hope you must have assessed yourself by now. So let's have a look at the answers. So the very first question was the 802.11 2012 standard was created by which organization? It was IEEE. So I discussed this in day 1 session only. The Institute of Electrical and Electronics Engineer is responsible for the creation of all of the 802 standards. Okay. Next question. What organization ensures interoperability of WLAN products? The correct answer is Wi-Fi Alliance. So again, it was discussed in day 1 session. The Wi-Fi Alliance provides certification testing, and when a product passes the test, it receives a Wi-Fi interoperability certificate. Question 3. Which keying method is most susceptible to interference from noise? So we all know amplitude shift keying, because as the noise interferes, the amplitude of the signal get distorted. So amplitude shifting key is most susceptible to interference. So this was discussed in day 2 session, that because of the effects of noise on the amplitude of signal, amplitude shift keying has to be used cautiously. Question 4. Which of the following wireless communication parameters and usage are typically governed by a local regulatory authority? So all the parameters are typically governed by a local regulatory authority. We discussed in day 1 that local regulatory authority define the transmitting, maximum emitting, frequency, bandwidth limitations of the RF. Moving to question 5. When an RF signal bends around an object, this propagation behavior is known as what? So friends, we discussed, I given a proper stress while defining or while explaining this term. Diffraction when your signal bends around the object, refraction when your signal moves or bend in some direction because of the change in density of medium, that is called refraction. So the right answer for this question is diffraction. So we discussed in day 3, often confused with refraction. The diffraction propagation is the bending of wavefront around an obstacle. Diffraction is caused by some sort of partial blockage of the RF signal, such as small hill or a building that sits between a transmitting radio and a receiver. Question 6. What is the frequency of an RF signal that cycles 2.4 million times per second? So we discussed in day 2 session. 802.11 wireless LAN operate in 5 GHz and 2.4 GHz frequency range. However, 2.4 GHz is equal to 2.4 billion cycles per second. Here it is 2.4 million, so it is 2.4 megahertz, not 2.4 gigahertz. Question 7. Which 802.11 radio technologies are most impacted by the destructive effects of multipath? So friends, I clearly explained it many times that 802.11n introduced MIMO, which makes multipath friend instead of enemy. Before that, all the standard has a destructive effect because of multipath. So A, B and G are the correct answer to this question. Question 8. What term is used to describe the time differential between a primary signal and a reflected signal arriving at a receiver? The correct answer to this question is delay spread. The time difference due to a reflected signal taking a longer path is known as delay spread. The delay spread can cause inter-symbol interference, which result in data corruption and layer 2 retransmissions. Question 9. Which RF behavior best describes a signal striking a medium and bending in a different direction? So bending in a different direction is known as reflection. Okay, if bending not moving in different direction, but because of bending it and change in density of the medium, it it moves from its right path to some deviated to some other path, then it is known as refraction. But bending in a totally different direction is called reflection. Question 10. The highest RF signal strength that is transmitted from an antenna is known as what? So that is EIRP, equivalent isotropically radiated power. So we discussed this in day 3 session. It is measure of the strongest signal that is radiated from an antenna. Question 11. Select the units of comparison. So friends, I hope you all know that answer very clearly, because only dBm is the absolute unit of power, rest all are comparison units of comparison or relative units of comparison. Okay, 2 dBd is equal to how many dBi? So we discussed this as well in day 4 session. To convert dBd, decibel dipole to decibel isotropic, simply add 2.4 to the dBd. So the correct answer to this question is 4.14 dBi. Question 13. WLAN vendor use RSSI threshold to trigger which radio card behaviors for roaming, dynamic rate switching? So discussed in day 4 session, the RSSI thresholds are key factors for client when they initiate the roaming handoff. And RSS threshold are also used by vendors to implement dynamic rate switching, which is a process used by 802.11 radio to shift between data rates. So I explained to you in our day 4 session that RSSI, there is no strict guidelines. There is a scale from 0 to some one, I forget the maximum range. So it's vendor proprietary how they implement this scale. They can take the higher number as the least one or the lower 0 as the maximum one. So it can be possible. It RSSI deployment is proprietary to the vendors. So but to make it more globally accepted, these two RSSI is used in these two behaviors, so for roaming and dynamic rate switching. Question 14. WLAN transmitter that emits a 100 megawatt signal is connected to a cable with a 3 decibel loss. If the cable is connected to an antenna with 7 dBi of gain, what is the EIRP at the antenna element? So the answer is 250 milliwatt. So if the original transmit power is 100 milliwatt and cable induces a 3 decibel loss, so we know 3 and 10's rule. So if there is a 3 decibel loss, power becomes half. The power at the opposite end of the cable is 50 milliwatts, because we reduce the power to the half. Then 3 decibel of cable loss half the absolute power to 50 milliwatt. An antenna with 10 dBi of gain would boost the signal to 500 milliwatt. So the signal gain will increase up to 5 milliwatt, but here the actual signal gain is 7 dBi. So we increased 10 dBi, it goes to 500 milliwatt. Then we reduce again 3 decibel, which again reduces it to half. The answer comes is 250 milliwatt. Okay. Question 15. Azimuth chart represent a view of an antenna radiation pattern from which direction? The correct answer is top. Elevation chart shows a side view. No, azimuth chart shows a top view. Which antennas are highly directional? So friends, parabolic dish and grid antennas are highly directional. Omnidirectional antenna. Patch panel are semi-directional, whereas sector antenna is special type of semi-directional antennas only. Question 17. A network administrator replaced some coaxial cabling used in an outdoor bridge deployment after water damaged the cabling. After replacing the cabling, the network administrator noticed that the EIRP increased drastically and is possibly violating the maximum EIRP power regulation mandate. What are the possible causes of the increased amplitude? The answer is the administrator installed a shorter cable. The administrator installed a higher grade cable. So discussed in last session only, installing a shorter cable of the same grade will result in less loss and thus more amplitude being transmitted out the antenna. A higher grade cable rated for less dB loss will have the same result. The ratio between the maximum peak voltage and minimum peak, voltage on a line is known as what? So the correct answer to this question is VSWR, voltage standing wave ratio. So we discussed in session 4 as well in last session. Voltage standing wave ratio is the difference between the voltage and is represented as a ratio such as 1 ratio 1 colon 1.5 colon 1. Question 19. What are some of the possible negative effects of an impedance mismatch? So the first answer is voltage reflection, erratic signal strength, decreased signal amplitude, amplifier or transmitter failure. So VSWR result in all these things, or impedance mismatch result in all these impact negative effects on your system. Amplifiers can be purchased with which of the following features? So friend, we discussed fixed gain, fixed output. So again, amplification can be bidirectional as well as unidirectional as well. So the correct answer is all the above options. The last question now. The signal between the transceiver and the antenna will be reduced by which of the following methods? By adding an attenuator, increasing the length of the cable, using cheaper quality cable. So attenuator is used only to attenuate the signal. By increasing a long length cable, definitely losses will increase. With 100 feet of cable, each 100 feet cable 3 decibel loss will be occurring. Using cheaper quality cable again led to the loss. So the correct answer is A, B and D. So friends, I hope I am clear with the explanation. Still, if you have any query, please feel free to share your feedback in comment section. Or in next video, we will start with our chapter 2, and we will again follow the CWNA syllabus context. And after each questions, after each session, we will conduct a quiz. Okay, thank you. Thanks for your time.